Hello, geometry class. I just want to take a quick second before we got started with this video to kind of let you know basically this is kind of our plan for the year. You will come in, you will watch the videos, and then the next day when you come to class, we'll go ahead and put that work together. So the good thing for you is hopefully if you work diligently, you don't have a whole lot of at-home paper pencil work. If you are slower in class, then you'll have to take that work home in class along with watch a video. The videos, I try to make them as short as possible. I know that you guys that had me last year like, yeah, right, but I do try to make them as short as possible, but you still need to get all the material. So you got to think about it like this. In class, we have 46 minutes to teach. So there's a good chance that in some of your classes, your teacher teaches for 46 minutes, and then you go home and you take your homework home. In math, a lot of times our lessons are anywhere from 30 to 45 minutes in class, and then you start working on your homework. The homework you could take home, and it could take you anywhere from an hour to 2 hours to do. So if you can get your work done in class, and all you have to do is watch a 30 to 45 minute video, which most of the time they're not going to be 30 to 45 minutes, then even if it is a 30 or 45 minute video, you're still making a good deal there because the homework will probably take you a little bit longer. Just a couple of caveats before we get started. Take notes on the videos so that way you have them, so that you have some study resources. Again, we talked about this a little bit yesterday. If you go on Blackboard, you can print out the notes that are already been created, but go ahead and take notes along with those notes, either by highlighting or writing in additional information that you may get. The other thing that you need to know is that there is a ton of vocabulary when it comes to geometry, starting with our very first section that we're about to talk about. Take that vocabulary. That is what that second notebook is for. Write your vocabulary in that second notebook. You can do it any way you want to. You can take the compilation of words that I created and put on Blackboard, or as you go through the notes, you can take the vocabulary down in your vocabulary notebook and then match them up and make sure you get all the words from that list. In any case, your vocabulary notebook should have every vocabulary word and the definition in there. That's just another centralized place for you to study. So sit back, or don't sit back, grab your pencil and paper, and get ready to take some notes as we talk about chapter 1.1, which is the introduction to points, lines, rays, segments, and such. All right, I hope you enjoy. Have a good day. All right, the first thing we want to talk about is undefined terms. These terms are, as you can see on the screen, terms that have no formal definitions, but there's an understanding of what they mean. First term I want to talk about, points. Points are just simply that. You're all pretty familiar with points. For example, right now we're looking at a point on a map, San Francisco. That's a point. A point has no particular dimension, and it's represented usually by a dot. What I mean by no dimension, it's not three-dimensional, it's not two-dimensional, it doesn't have any kind of volume, any kind of surface area. It's just, like I said, a point. It's pretty self-explanatory. You see points all over the world. In math, we oftentimes see points on Cartesian planes, such as this one here. Points are usually determined by an x and y coordinate when you're talking about a Cartesian plane, but we can use points for so much more. Again, in algebra, you should be familiar with the points on a coordinate grid, Cartesian plane, stuff like that. This particular point is located at 12 on the x-axis and 14 up. Okay, points are also labeled with a capital letter. This is just a way to label the points. You can see here, this is another example of a Cartesian plane with multiple points. Points are often found all over. It's not just usually a single point. Just like a map or a globe, you see a bunch of different points. Points are also found in our geometry world, or even algebra world, or overall in math world, in in segments. A segment, such as this here, is where two points are connected together to create some kind of line. Most of you guys are familiar with line segments here, but we use points in order to create line segments. Notice that there are 5 points that create this line segment, or you have 4 quadrants created by this line segment. Okay. Again, points are also used to create lines. Lines, such as this line here, are created by points. Lines are full of points. Infinite number of points create lines. And I think that most people are unfamiliar or not aware of the fact that lines are created by points. Again, points are just simply points, and they are labeled by a capital letter. Very, very, very simple, very easy, the most basic part of this geometry lesson. All right, the next thing I want to talk about are lines. Okay, we just talked about lines just briefly a second ago with the points section. Lines, again, are found all over the world. You could probably look around the room that you're sitting in right now and see tons and tons of lines. Lines aren't always up and down, horizontal and vertical. Lines are often found diagonally or slanted, but there are tons of lines throughout this world. Like you can see here on the sidewalk, this little particular sidewalk is created by lines. As you continue to look throughout the world, we also have noticed power lines. Power lines are found all over the world, which guide electricity, but they are parallel lines a lot of times. Hopefully they're not perpendicular too often. I'm sorry, intersecting too often. But power lines are another example of real world lines. Here's another real world example of lines. These are the lanes on a pool. There's also lines on the bottom of that pool in order to see so to help the swimmers see where they're going. If you're watching TV at home, if you're watching Olympics, you see the computer generated yellow line, and then there's of course those lines from the flag. So again, lines are found everywhere in the world. It's pretty hard to avoid them. So what does that mean for us in geometry? What are the basic things that we need to know? Again, a line has one dimension. Okay, it is represented, a line. Every single line is represented with two arrows at the end. This is something that we try to teach in Algebra 1, that when you create a line like on a Cartesian plane, you must put those arrows on there. That indicates that it goes forever and ever. If you don't have the arrows on there, all you've done is created a line segment. Again, lines are made up of dots, multiple dots, infinite amount of points that we call dots. Okay, lines can be perpendicular, which are two lines that intersect to create a 90-degree. Lines can be parallel. Those are lines that will never ever cross. Or lines are intersecting. Those three different examples are represented in this drawing here. Okay, so how do we identify or label lines? Lines are labeled by using the 2 points, or 2 of the points on the line. For example, here this is line AB, and the other one is line GE. Okay, those are ways to label the line, so you can use any 2 points to label a line. The other thing that you could do is also label a line with a lowercase letter. Okay, that's another way to label a line. So if you look here at this particular example, you have line D, that's lowercase, and that identifies that line, line Y, and there are a couple other lines identified here. Okay, the next thing we are going to talk about are plane, okay, or planes, if you will, but it's called a plane singular. And no, we are not talking about these type of planes, of course not. That would be too interesting and too much fun, so we're going to stick to just the algebra, just the geometry, which does include this type of plane, however. This is actually a plane in the real world. This is the end zone at Cowboy Stadium, for those of you guys who don't know. This is a real life plane. A plane has 2 dimensions now. Okay, it is represented by a shape that looks like a floor or a wall, and it extends without an end. Okay, so a plane can go on forever. Now, this particular example of the end zone at the Cowboy Stadium has an end, but it is still representative of a plane. And it's interesting because when you hear on the Cowboy games or whatever, they'll say, did it break the plane of the end zone? Did it get into that end zone? Okay, so how do you label a plane? You label a plane with 3 points that are not on the same line, and that makes up a plane. Or you can use a capital letter. Okay, so right here, this would be plane ABC, unless you designated it with another type of letter. Planes can intersect one another, as you can see here. So these are 2 planes that intersect one another. This is plane A and plane B, labeled by a capital letter, that are intersecting one another at line L, if you see that line labeled there with a lowercase l. So planes, again, are basically made up of 3 points that are not on the same line. Because if the 3 points are on the same line, then you have created a line. So this is a plane. 3 points not on the same line. Okay, now we're going to talk about some of the defined terms I said earlier. Segments is the first one that we're going to talk about, also known as a line segment. Segments are created by 2 points. Segments are found everywhere. Again, I want to use the example of a football field. From side to side, you can find a bunch of segments, like where that the 10-yard line is. The end zone, or actually that plane, is actually enclosed by segments. Segments can run east and west, north and south. There's segments all over a football field. So that's why I put that example up there. Just look at all the different lines that are not infinitely long through that end zone. Again, a segment is made up of 2 points, such as here, there's a point A and a point B. And these line segments basically put an end to the line. If I had arrows on the end of this, it would just be in a line that goes on forever. But because I have two endpoints, A and B, then I have created a line segment. Okay, and it is written with the capital letter A and B, and you'll need to refer to your textbook to the ways that it differentiate between a line versus a line segment. A line segment just has a simple line over the top of it that indicates it's a line segment. When you identify a line with the 2 capital letters, then you put a line with 2 arrows over the capital letters. And on an endpoint, every point in between the endpoints are on that line segment. So in this case, line segment AD is made up of line points B and C as well, not just A and D. The next defined term that we are going to talk about are rays. Okay, rays are a defined term like line segments. No, we are not talking about the Tampa Bay Rays. We're just talking about rays in general. So when we talk about a ray, we're talking about, again, we have to use that term endpoint because a ray is a line coming out of an endpoint, basically. It consists of an endpoint and then all the points on a ray, on a line that go in the same direction. Okay, so for example here, A is the endpoint, and then B is a point on that line, but notice that line only goes in one direction. It has one arrow that shows it goes on infinitely in that direction, okay? Whereas a line has 2 arrows going in both directions, it goes on infinitely in both directions. A ray only goes infinitely in one direction. Rays can be put together to create angles such as this one here. And when we identify a ray, it's just like identifying a line or a line segment, except above the capital letters are going to be a little mini ray that points. The endpoint must be the letter that is put down first as well. So that is the basic information of a ray. Okay, and that is not the end-all be-all of chapter 1.1. There's some other important information that you need to know. You'll get a lot of that information by writing down all of your vocabulary out of your textbook into your vocabulary notebook. But some other information that you need to know that you'll learn is collinear points, coplanar points, endpoints, opposite rays, which actually create a line, intersections. And again, if you put all these words into your vocab notebook, this should be easy and you should be ready to go to do your classwork when you come in on Tuesday.